We often use AI to process PDF documents, and they frequently include images. How well can AI accurately handle these images? We have seen some market promotions claiming that their large language models can process charts very well, with impressive performance figures. Let's conduct a real-world test to find out. When Claude 3.5 Sonnet was launched, it specifically featured improved performance in chart Q&A. With reported accuracy rates of over 90%, this figure was around 80% just 3 months ago. We were using the paid versions of ChatGPT, Gemini, and Sonnet to ensure a fair test and see how they perform. For the first test, I choose a quarterly report from Tesla, which includes several charts and tables. Most of the data in these charts is also available in table format. But I specifically focused on a chart that contains unique data, global electric vehicle adoption rates, that wasn't replicated anywhere else in the document. If an LLM can accurately extract the data points from the chart, like reading the adoption rate for a specific quarter, such as Q1 2017 or Q4 2020, then we can say it truly understands the chart. So I uploaded the same document to each model and asked them to extract the data. Here is what happened. Gemini remained silent on the matter. ChatGPT and Claude both identified the chart on page 12 as relevant to the question, but also couldn't find the relevant data. None of these models managed to extract the numbers accurately. I tried splitting out page 12 and uploading it separately, but the results were the same. For the second test, I decided to try a different approach. Instead of uploading the entire document, I took a screenshot of the chart and saved it as a JPEG image. I then uploaded this image to the models to see if they could interpret it better. This time, the results were somewhat better. ChatGPT and Gemini came close to identifying the numbers, but still showed some inaccuracies. Claude made an error, thinks the global rate was 12%, but China had to be subtracted from the rest of the world. Regardless, this time, the models at least recognized the chart. Claude had a conceptual error, but the numbers themselves were accurate. The other two models' numbers were also close to the correct values. Here's an interesting point to consider. Many charts in reports, like this one from Tesla, are not just raster images, but vector graphics. Vector files are essentially code, meaning they can be infinitely scaled without losing quality. This poses a challenge for AI models because they might skip over this code instead of rendering it correctly as a visual chart. In our tests, this issue became evident as the model failed to recognize or accurately read these vector graphics. In the end, while these models are powerful tools, they are not yet perfect for tasks involving complex visual data like charts and graphs. If you rely heavily on these features, it's essential to be aware of these limitations and use them accordingly.